Hello everybody. Okay, this is Mr. Murray and we're going to start a unit on graphing trig functions. And to do so, what we usually do is this thing called unwinding the unit circle, which is just a fancy way to say that we're just going to graph some sine functions or cos functions. You might recognize these shapes, but just so you know they didn't come out of thin air, we'll just take them out of our unit circle and show you what it looks like. So in this first example, I'm going to do sine just to show you. So what I have here up in the chart is from 0 to 180. So we can call this 0, 30. So you have 45, 60, 90, 120, 135, 150, and 180. Now for sine, this is nothing new, you know this. As you go around the unit circle, what is the sine of 0? Okay, well that happens to be 0. The sine of 30 is a half, 45 is radical 2 over 2, radical 3 over 2, and finally 1 at 90 degrees up here. Then we keep going around the unit circle, and we go back down to radical 3 over 2 for 120. Then we go to radical 2 over 2, 1 half, and then back to 0. So imagine we were to graph these. So if this was 30, and then this was 60, 90, 120, 150, 180, and then we continued, and you'll see why I'm going up here in a second, 210, 240, 270, 300, 330, and sorry, 360 out there. Okay, so let's do a quick sketch. At 0 degrees, what do we have? At 0 degrees, we have 0. At 30 degrees, we have a half. So let's label our y-axis, maybe 0.5 and 1. And this can be negative 0.5 and negative 1. So check this out. At 30 degrees, we have 1 half. At 45 degrees, we have radical 2 over 2, which is just around 707, right about there. At 60 degrees, we have radical 3 over 2, which is 0.866. It's almost at 1. Then when we get to 90, we are at 1. Now you'll notice this is very symmetrical, so it just works its way down the other side. So over here, radical 3 over 2. Then we have radical 2 over 2. Then we have a half. And at 180, we have 0. Now check out this really cool curve. Watch. If we connect these dots, it goes like that. Now, as we work our way around the other part of the unit circle, so that was just 0 to 180, right? As we go back from 180 through 360, it just ends up repeating itself. And at 270, you know we're down at negative 1. And watch what happens. Cool. Okay, so at the end it was a little cheesy. But this is the graph of a sine function, and just as the unit circle can go around and around and around, this just keeps going and going and going forever. So let's take a look at this graph called sine. What would the domain be? Well, that's easy. Left and right, all real numbers. What about the range? Well, if you notice, it doesn't get much higher than 1, and it doesn't get any lower than negative 1. So that's my range. Y is greater than or equal to negative 1, but it's also less than or equal to positive 1. Where do the maximum values occur? I see it right here. But since this repeats over and over and over again like this, you're going to get maximums constantly. And the place that you'll get maximums will be 90 degrees for sine, and then every 360 degrees after that. Because if you look at the unit circle, at 90 degrees, the sine value is 1. Where will it be 1 again? Well, if you go around one more time and add 360, it'll be 1. Or if you subtract 360 from 90, it'll be 1 again. So any angle that's coterminal with 90 degrees will be where this maximum occurs. So we could always write it like this: 90 degrees and 90 plus or minus 360. Same thing for the minimums. The minimums happen down here, wouldn't you agree, at 270? That's where we hit the low point, -1. So 270 and 270 plus or minus 360. Does this function have symmetry? Yes. It's pretty cool, actually. This function has point symmetry through the origin. So yes, point through origin. And therefore, because it has origin symmetry, this function is odd. Okay, so that's an introduction to the sine curve. And now let's take a look at cosine. We're going to go through the same steps. We'll just take a look at the coordinate on the unit circle for cos, and we'll graph it. It looks very similar. It just starts in a different location. So let's take a peek at that. Okay, so at 0 degrees, cosine actually starts at 1. And then at 30 degrees, it's radical 3 over 2. At 45 degrees, it's radical 2 over 2. At 60 degrees, it's a half. And at 90 degrees, it's 0. So you get this nice curve like that. Let me finish filling in the rest of these. It's really, really cool. And then, of course, over here it does the same thing. It just starts to head back down. It's like a wave in the ocean. Very, very symmetrical. And it just keeps repeating and repeating and repeating. So that's the cosine graph. One of the main differences between sine and cosine that you'll recognize is the starting point. You know, cos always starts up there at the high spot at the origin. It goes all the way up to 1. And why? Well, that's just because that's what the cosine of 0 is. It's 1. So check out the sine graph. You can see that it started here at the origin and started heading upward. Whereas the cosine graph already starts at the top of the curve and starts heading down. And then it just continues its journey. So very similar. The domain is all reals. The range is y greater than or equal to -1, less than or equal to 1. In this instance, the maximums are occurring at 0 degrees and anything coterminal with 0. The minimums occur down here at 180 and anything that's coterminal with 180. Does this function have symmetry? Yes, it has y-axis symmetry. You can picture this folding over onto itself. So yes, y-axis. And therefore, it is even. Cool. Okay, so that's cos. Okay, so now thinking about graphs, let's get some definitions down. Cycle. One full rotation of the graph. And what I mean by that is this. A full rotation just says Let me go to my highlighter, and we'll pick this guy right here. Starting from any point, go until you get back to where you started. Bam. That's a single cycle of the cosine graph. And if we look back at sine, pick any point, and let's travel along the sine graph until we complete one rotation around the unit circle and get back to where we started, right there. That's considered a cycle. Okay, so that's for your definition, for your notes. Okay, next. Period. The interval required to complete one cycle. In other words, how long did it take? How long did it take to go from here to here? How long was that interval? You can see it was from 0 to 360, right? So my interval is 360 degrees, or 2 pi, because that's how long it took to complete one cycle. The interval was 360 degrees. Midline. Midline is important for the next definition. Midline is basically just the horizontal line that can split your trig graph into two equal halves. So let's take a look at that. Okay, my midline here, let me change the highlighter again. I'll go with pink, purple. This would be considered my midline right there. Because as you can see, it puts the graph right in the middle, right? It puts half of it on top, half of it below. And that's important to know the midline because of our next definition, amplitude. Amplitude is just how high is this thing? You know, how tall has this graph gotten? But in respect to the midline, it's just not the number on the y-axis. So for example, looking back at maybe the cosine. The amplitude here is 1, but it's not 1 just because it crosses at the highest point at 1 and the lowest point at -1. That's not the reason, just coincidental. The reason why the amplitude is 1 is because that is the distance from the midline to the highest point on my graph, or the distance from the midline to the lowest point of the graph. And what you do is you take the absolute value of that. So I wouldn't say my amplitude here is -1. I would still just say it's 1. So let's take a look at our definition and make sure we covered that. Yeah, the absolute distance from the midline to the high or low. That's how you calculate amplitude. Okay, very good. Next set of notes. This is what one of these trig equations look like. A sine bx plus c plus d. And for today's video, we're only going to worry about this, the A and the B. We will do the C and D another night, okay? So let's take a look at what I have for you here. What does A represent in the standard form of a trig equation? Okay, A is the amplitude, what we were just speaking about. And a couple of things to notice. If your A is bigger than 1, your graph's going to get really tall, right? Because that's the distance from the midline to the high or low. If your A is small, less than 1, well, that means that that distance is getting smaller. Your graph's going to look really, really tiny. You know, so it'll be like itsy bitsy spider like this. Whereas if you had a really big A, you're going to have these huge swells of ups and downs like that. Okay, and also just to know, if your A happens to be negative, just like the parabola, your graph will reflect over the x-axis. You'll notice that many of these transformations are identical to x squared. They really are. They follow the same rules. Okay? All right, next definition. B. What does the B do that we'd like to talk about tonight? That just identifies how many of those cycles you're going to have within 360 degrees. So taking one last look back at that graph we did of cosine or sine, whichever one, let's see. Okay, this guy, cosine. Look at this cycle in green, right? You would agree that that's one cycle of the graph. Well, that means my b is equal to 1 because I did one cycle within 2 pi, aka 360. Now, if I want to do a bunch of cycles within 360, well, this thing would be super duper fast. I'd be going up, down, up, down, up, down, up, down. Or if I wanted to go really slow and make my b less than 1, this thing would barely get to the end of the graph like this. Really slow cycles. Okay? So back over to our notes. Now this b number, like we just said, if it's larger than 1, the graph's going to get really, really fast. And it's going to look like this. It's going to just be jumping around like a heartbeat. Now if the b is less than 1 in the equation you're given, it's going to be really drawn out like a slow turtle, like that. Okay? We'll learn more about that later. Don't stress. Okay. Now, period, which you recall is how long does it take to complete one cycle. I'll show you one last time over here. Remember this blue line here represented period. It was the length of the interval to complete a single cycle. Well, there is a formula for that. So once we start talking about A's and B's, then you're going to be able to use this formula, which says your period can be found by just simply taking 2 pi, or 360, and dividing it by that letter B. And that'll tell you how long each cycle takes, or what the interval is. Okay, so let's do a couple practice problems, and then you could do your classwork. Where's my midline? Keep that in purple. Right here at the x-axis. Okay, that's cool. So using that, I can find out the amplitude because it's the absolute distance from midline to any of the maximums. And that would be 1, 2, 3, 4. Okay. A is 4. Now, how many cycles are happening within 360 degrees? So let's go back to my highlighter. We'll pick green. Let's highlight a cycle. Now for cosine, it would just be like peak to peak. So I can go like this. Here's one cycle, peak to peak. Now I want to ask myself, how long was that? And if I look, 360 degrees. So how many cycles did I do within 360 degrees? I did 1. So B is 1. And my period, which we just figured out, is how long was that one cycle? 2 pi over B, or 2 pi over 1, which is 360 degrees. That's my period. Cool, next graph. Okay, where's my midline? Midline is here. Oops, sorry. Get out of here. That's my midline. So from there I can find my amplitude by measuring this distance. I count out to be 3, so A is 3. My B is how many cycles occurred in 360 degrees. So let me take the highlighter again. We'll take a look at maybe light purple. Okay, here's a cycle. Ready? It's one cycle, 2 cycles, 3 cycles, 4. Okay, B is 4. Found it. Now what's my period? In other words, how long is just one little cycle? I could count degrees here. I mean, it's looking to me to be like around 90 degrees to do one cycle. But let's use our formula. It's 2 pi over B, In our case, that would be 2 pi over 4. Let me get rid of this a little annoying thing. Hang on one second. Okay, cool. Okay, 2 pi over 4, which is pi over 2, 90 degrees. We were right. Okay, so there we go. Next graph. Okay, last one. So back to the highlighter. Let's see if we can't find our midline. Again, it's usually the x-axis until we start messing with it later on. What's our amplitude? That's the distance here. Okay, that's 2. B, how many cycles? Okay, let's go back here. Let's pick yellow. Cycle, top to top, right? So, oh God, look, I'm already at 360. Right there. I couldn't even do a cycle in 360. How many cycles did I do? I just did half. I went from top to bottom. I was on my way back up to the top when I realized I just passed 360. Okay, that's fine. That just means how many cycles did I do within 360 degrees? I did a half. I did half of it. Now that'll affect the period, right? Because period is 2 pi over b, which in our case is 2 pi over half. Wow, so that's going to be 720 degrees. Well, that seems right because watch, let's go back and trace this and we'll see that if I did finish the cycle, I would stop right there and there you go. One cycle, 720 degrees is my interval. So that's correct. Period is basically how long does it take to complete one cycle. So notice what happens when b is small, this graph really slows down and stretches out. Whereas if the b is very large, the graph gets very, very, very quick. Okay, let's look at some equations, then we'll be done. All right, for this guy, what's my a? 3. What's my b? 2. Remember, this is a, that's b. What's my period? 2 pi over b, or 180 degrees. Next guy, my a is 2. The negative just shows me that it reflects. You're not going to have an amplitude that's a negative. Remember that. B is a half. Period is 2 pi over a half, which is like the last example we did, 720 degrees. Last one. This is A, this is B. My amplitude is a half. How many cycles am I going to do within 360 degrees? 4 of them. Think about what we're saying before we close this out. If I've got 360 degrees here, 0 over here, and I'm going to do 4 cycles of cosine, look how fast this has to be. There's 1, there's 2, there's 3, there's 4, right? Look how quick it gets and how tight it gets. So if you imagine the period being just the distance of one of those cycles, it's going to be very small. It's going to be 360 degrees divided by 4, which is 90. That's a pretty quick period. That's why it's booking so fast. All right, I hope you had a nice time watching this video, and good luck practicing during class with the sample problems. I'll see you tomorrow night. Take care.